Hi, everyone. Welcome to another episode of the Common Lisp Study Group. I'm your host, Ron Batum with Atlanta Functional Programming. Today's discussion to drop a line either in the comments and we'll kind of, you know, um, address them as they come along, either through the YouTube discussion or not. And if you're actually watching this live, feel free to add your questions in the live chat as well. Before I begin, I wanted to kind of remind everyone, especially our viewers, if you like what you see, please subscribe to the Atlanta Functional Programming channel for more videos on Common Lisp, as well as videos that we tend to record of our talks. As many of you know, Atlanta Functional Programming is a meetup that promotes the functional programming paradigm, or tries to promote it as a complementary paradigm for the design of large-scale systems. And as a result, I would appreciate folks who are enjoying our content to please subscribe to get updates whenever we have recordings and talks and so forth. If you want to keep track of upcoming talks, please join our meetup. That's over at meetup.com to get updates and notifications. Live streaming usually ends up having its links notified about 15 to 20 minutes before the actual stream starts. Although today we started a little later than expected. Um, Hold on, I'm having some technical difficulties here on the YouTube stream for some reason. Give me just 1 second. Uh, it's saying that these it's having some issues with the stream, but I don't think I can experience that. Folks who are watching the stream, you might have some buffering issues just ahead of time, just mainly because I'm having some connection issues that I don't think I have control over. I'm going to try and see if I can address them as we go on. Um, Before our discussion last week on Ask Us Anything, where we had a pretty generic discussion of various topics, we were covering the cl-neo4j library, and I kind of mentioned that there is some refactoring. Was some discussion that I created, some packages that I created as part of that refactoring effort, and now if you download the cl-neo4j library based on my project. I'm going to try and get this hooked into the main line. I'm going to submit an initial pull request with these changes. Um, I think it's at a point now that I got all the old unit tests passing. I need to write some new unit tests for some of the stuff that we added last week as part of the transaction API. Well, the week before as part of the transaction API still. But this looks good enough for folks to actually use, at least if you're using the older API, since um, the the test results is no better than what the test results were when we had when it was last submitted inside of mainline. In fact, they match exactly. There's kind of one test failure that I'm still looking into that was even there in the old API, but I have to go in. I mean, sorry, the old implementation that's on the origin branch, but I will address that when I get a chance. Today, we're going to be continuing our actual exploration of CYPHER, because last 2 weeks ago, I gave kind of an overview of CYPHER, basically at the point for a couple of basic queries. One of which was the uh, create statement. Another one was match. How do you use match and delete? How do you go and delete stuff? And we actually played around with the front end interface, and we actually created, if you recall, in our transaction um, code, something called transaction delete node and transaction get node that would actually give us some of the stuff that we kind of expected if we had the node ID for getting the actual node itself. Um, and we wrote these basic queries here where we have get node ID by query and create node by ID by query to actually get stuff. And we ended our discussion actually. 1 second. Oh, 1 second. Oh, thank you. I appreciate. Can folks see my screen? Okay, excellent. Kind of attempt to actually creating a relationship query. Now, just as a reminder for folks who weren't there, or even for folks who who are new still to Cypher, in Cypher, and I think it's probably best for me to first share probably the Cypher, sorry, the Neo4j front end interface to explain this first. Let me pull that up here. Give me a second. Okay. Never, not now. Okay, let me quickly share this guy. This. Okay. So when what we were attempting to try to do is actually add relationships to kind of movie objects that we've created inside of our actual database in an effort to actually go in and uh, create new relationships dynamically. This can occur, like, say, in a real system, you're trying to actually create your entities first, and then as you are learning through some data, you figure out the relationship between two entities. You want to add that after the fact. So this is kind of the situation that we were trying to end up doing. Um, so one way of handling this was add we were trying to create a generic query that actually does this. And so I thought it would be best to kind of just quickly cover one of these things, just as a kind of a quick review. Um, so first, let's go ahead and do one thing. Let's grab our nodes. Um, and this is match a movie, just as folks who may have seen this. This is just a quick review. This is how to get a generic things. It seems that we do not have any more records here. Um, let's go ahead and add a couple of records just for the sake of example, very quickly, using our our previous things. And I'm just going to quickly just do this behind the scenes. You will see it once I run our stuff. Oh, I'm in the wrong thing here. That's right. I actually have, I think I'm running, yeah, I'm running the wrong Neo4j 3.5. I'm running 3.5, not 4.0. I have to start Neo4j. Okay. And let me go ahead and refresh this. Um, 1 second. I think it's just taking a second. Hold on. It looks like my database got messed up. Not a huge deal here, because I've been stopping and starting it multiple times when I think it got messed up here. I'll just quickly create a new one. Not a big deal. We kind of covered all this in the background. What I'm doing is I'm just creating a new storage volume, and then creating just hooking this up into a new instance of cl-neo4j here. Docker run. That's fine. Okay. And let me just get this going. I apologize, I have to reset this. This happens sometimes. I have to just set up a new password here. Okay, and now very quickly, let me just go ahead and do this. And oh, right. This is let's very quickly do that. Then oh, right. I forgot to do this. Oh, right. I forgot to update this guy. Give me a second here. I wrote some stuff in this scratch buffer that I forgot to update when I did the refactor. See this cl-neo4j user. Oh, right. And oops. Okay. Type O. And done. Okay. So now when we do a match, I don't even have to do that because okay. What the heck? That should have actually worked. Give me a second here. All right, let's switch to my, very quickly, let's switch to my Lisp buffer to do some debugging. All right. And let's see here. For folks who are okay, let me just do this setup. Actually, why am I doing that? I could just do this. I think I have this already loaded. Right, okay. I should have actually cl-neo4j. This is actually something that I wrote up. Do tx create node ID the test movie, grab this guy, and what is it? These are key arguments, right? Let me go back to, sorry. This transaction, that's what I needed. Tx create node is key types. Okay. Okay. CLG, URI is unbound. 1 second. Did I forget to fix that here? Oh, I forgot to commit that. Okay. This is now utils and second. There's some style warnings that I'm getting. Undefined function for Neo4j output. I thought I had already saved these changes. It looks like some of my changes got retroactively incorrectly passed over. Okay. Not a problem. I know what I have to do. This is also in this area. Shift G, JSON, Neo4j defined, never used. Of course, it's not. This is happening because of the fact that when we do a macro expansion, since everything's coming from now the utils package, and I don't expose all of that stuff, as we saw before, the macro expansion takes in the symbol that is most external to, that is most visible to the package, and it'll actually inject it into the actual code itself. But in this case, body and URI are internal to the package. So I'm being forced to actually use : to get those specific things passed over. And that's just causing some issues, but that warning is not a big deal. When you see this, I don't think that should be a problem. That shouldn't affect the actual execution of this. Transaction node does not condition. Oh, right. This is now supposed to be what is it? It's in yeah. This should be cl-neo4j .utils node. That's it. There we go. Node not found tx. What? Hold on. Setf drachma. Where is the header stream? Header stream standard output. Okay. And let's run this guy again. Okay. 404 not found. What is the actual commit that it's getting? Uh-huh. Okay. I thought I fixed this already. Must have done something wrong. Hold on 1 second. Projects. Oh, I did not. Okay. So I fixed the old API, but forgot to update to make changes in my new one. Okay, that's not a big deal. I'll go fix that. This one I need to actually change by in the URI spec. I have to actually provide sorry for the silence. Just give me just 1 second here. I'm just looking at just one thing here. All right. So it looks like what I've done is I fixed the old API, but forgot to add one thing that we fixed a few weeks ago with the newer one related to the URI pointing to /db/data. And that's because, if I'm not mistaken, I have to go in and change the database. Right. Okay. I think I changed that in the database. Okay, with the handler task, basic handler cl-neo4j DB. Right. Okay. So I just got to go and change the cl-neo4j database to being the newer one, which I forgot what it was. That's going to be 74. Right. Okay. All right. So go here, change setf cl-neo4j.utils neo, because I forgot to export this guy. Not cl-neo4j.utils, cl-neo4j.utils database to being neo4j. Okay, now try this. There we go. And let's go to neo4j.lisp and let's just go ahead and run cl-neo4j.transaction. I think it's that. Hold on 1 second. Yep. Okay. And let's go ahead and correct this. Giving node ID, node type, node properties. Okay. So we now have 2 changes here. Let's go back to our share as we saw last time. Rerun this query. We should have 2 nodes, which we'll see in the graph. And what we're trying to do is essentially create a new match query that basically takes if you're adding relationships, for example, what you have to do is if you recall what we did last time you have to first find the nodes, and then you have to create the new relationship. Um, so um, so the way you do that is you first find you first write a match query that we started this earlier in our previous discussion in this. Um, and the way you do this is this. Um, let's create a very quick thing here in our thing. One more thing we need to create, which is an actor. Let's go ahead and create one actor here. Okay, a person. Let's do that. Name, let's say Keanu Reeves. Okay. We can always add more stuff later. We have now, wait, did I mess that up? Oh, yes, I did. Okay. I think I have to do this. Expected a parameter. Oh, wait. Sorry, I used the key name. It should actually be name like this. There we go. Okay. And what we're going to do is we're going to say match a person where a dot name equals Keanu Reeves and match and we're going to expand this a little bit so we can actually write this with several things here. Oh, dang it. I need to do this way. Match B movie where B dot title is the matrix, and we do merge A acted in B. So this is the syntax, if you recall what we're trying to do. Let's play this to make sure. There is one thing that I might be missing here. Give me just 1 second. Let me go and remind myself here. Yes. I have to make those actual nodes. That's right. I have to say B and A. And there we go. So now if we go in and create a match of a person C B movie return ABC, we'll get our acted in here. So we're going to try to mimic this guy inside what we did last time, okay? And originally what I was trying to do when I was trying to create this query is I thought I would create a function for this. Um, Um, so uh, let's go back to our. Hold on, there was a comment here. Yes. Just a general thing. I'm just gonna hold on. I have to answer just a quick question here. Um, this tutorial. Um, uh, yeah. So now, um, so where was I? Yeah. So there is a discussion here that needs to be thought of, which is how might we go and express this? Okay. One way that I was thinking of doing this is actually doing the match merge exactly the way I was showing you there, where we tried to grab some metadata information and we tried to actually go in and do the merge physically, where we do all of it at once. But what we're ultimately doing here is actually all of these functions here are actually just nothing more than pre-canned procedures. All right. So there's a couple of ways to actually go in and uh, handle this. One is inside Neo4j, and I'm not going to really cover this. This is actually something that's not really list specific, but it's actually part of Neo4j. You could do something called prepare. It's kind of like prepared queries in SQL. You could create a prepared query inside your Neo4j database, and those will take in parameters, and then you can inject those parameters into Neo4j, as we saw, as part of the format. As you see here, these parameters here are basically based on the Cypher query generation that you're creating inside statements. And each of these can be multiple statements that are within a transaction. But what I think would be more useful, at least for our Lisp wrapper, is an actual um, macro that will generate this, this, or any other combination for this. So I thought we could spend a little time, at least today, designing what we'd kind of like, and then for the next couple of episodes, um, figure out how we might leverage the macro facilities inside Lisp to actually generate what we want. So this is kind of going to, the purpose of today's discussion is really more of a design discussion on what do we ultimately want to generate. And then during this, I'm going to give a brief review of some of the macro facilities that we've already covered in previous episodes, particularly reader macros. In this case, we'll leverage either reader macros, regular macros. Um, we won't cover, I don't think we need symbol macros or compiler macros in this case. Um, that I think might be overkill. But we need to obviously determine that based on what is our ultimate output. What are we trying to code generate? Okay. So brief review on macros. In Common Lisp, macros is a way to perform metaprogramming. Okay. Many of you has heard me talk about macros many times on this channel. We I've always kind of leveraged macros into types of macros in Common Lisp, much akin to like LLVM and compiler frameworks, mainly because a lot of what people talk about when they talk about compiler frameworks is the fact that it is modularized, so you can only handle particular aspects of the compiler tool chain that you want to customize when and where it's appropriate. So in this case, if you're saying that you want to take non Lisp syntax and make Lisp syntax, you could create what's called a reader macro. All right. This is much like a parser if you're writing a new language. All right. If you're doing Lisp to Lisp transformations, so you're trying to take a piece of duplicate Lisp code and you just want that to get injected into a uh, source code transformation, you would use a regular macro. That's your def macro. All right. We'll see the differences between these things when we start writing and designing this particular macro. But this is again another brief review. The other thing that you want to also keep in mind is compiler macros, which is something we're not going to necessarily cover today, but based on performance and stuff, we may have to cover at some point, because compiler macros basically allow you to take the Lisp code that you took from your previous reader macro and regular macro generation and perform optimizations before ultimately sending it off to the code emitter to actually generate your assembly code, if in the case of compiled functions, or in the case of interpreting functions that will actually go into the evaluation cycle and actually evaluate. And what that does is it allows you to take what you probably learned in a compiler's course, several techniques to do things like, say, domination analysis or liveness analysis, or um, doing boundary checking and things like this. And you can actually go and optimize the Lisp transformation code at that level to actually go in and generate more efficient Lisp code that will actually create what you want in terms of assembly generation. Or in the case of eval, it'll speed up your evaluation. Okay. Um, for the purposes of a query language, we can leverage some of these aspects to a certain extent. I'm not saying that I'm going to try and tackle the query planning problem in this discourse. All right, I'm just going to handle a very low hanging fruit, which is we're writing a lot of functions that essentially do the same thing. You're injecting some parameterized code into a standard string. All right, and uh, sometimes this will handle a good portion of cases, but not all. And what we ultimately want to do is be able to take Lisp code, all right, and spit out the query that we ultimately want. So what do I mean by that? So one primitive idea that I came in and started thinking about is well, what if we had something like, say, um, cipher query, and then it generated something like create, and then you provide, um, much like what you see in Cypher. Um, let's see, a a person, and then in here we have uh, name Keanu Reeves. All right, okay. And what this does is it will generate what we expect it to. It will look at it outputs nothing more than um, create a person, name colon Keanu Reeves. All right. This already will give is pretty useful, because now we're working in the query language that the database is actually providing us. Okay. This is not technically Lispy in the sense that we're still using a function call to determine what we're actually creating. So this side is probably a Lisp expression, but within here, the parentheses mean a node inside of a graph. All right. So this is a kind of a design thing that I've been thinking about. Just what would be the most Lispy way to actually express this? And one thing that I thought would be useful to tackle is something more like this, where you say cipher query and you start writing multiple things like a person, name Keanu Reeves, and sorry, it should be this way. Okay. And then we could do a semicolon, or we could start writing see, unfortunately, with the semicolon, since it's a comment, we can't necessarily use a semicolon to write multiple statements. Um, it'll be useful to be able to write something like this, where actually, let me change this one here and say, instead of colon name, because that's a lisp-y way of doing it, this is our actual creation, and then the generated code will be our output of the above example. Should be expected would be create okay, and really it's not a person. You want to do really Keanu Reeves person, just like what we did before, because you want to really have labels on your on your um on your nodes inside your graph to make it easier for yourself. And it will do name colon Keanu Reeves. Okay, and it'll output that. Obviously, we want to be able to write multiple queries. So one thing from this expansion is you could write more. Let's say that you you want to do multiple things. You could go ahead and write out a generator that, be able to write something like this, and write, what we saw earlier, which is, let me just get my example that I wrote. Hold on, where is it? This one. Okay, this one here. If we wanted to write this, we could go ahead and write create the matrix movie, and then write title the matrix released 1998. Okay, and then it will generate what we saw earlier with its CYPHER query. Okay, the thing about this is and this is where reader macros come in, is we are essentially telling Lisp that this is starting to be the start of a reader macro. When we start encountering any Lisp expression in the reader macro, the parentheses doesn't necessarily mean the start of an S expression. The parentheses is going to be start of a potential query that we're going to try and add. Okay, and this would allow us to write multiple statements inside of a single query, um, and be able to spit out an appropriate string that will end up getting passed over to uh, the HTTP API. This design would then also allow us to write, say, CYPHER query, things like for merging, like what we saw earlier. If we did match a person where a dot name equals Keanu Reeves, okay. And I already know what people looking at this are already getting kind of queasy, because this is going to remind them of loop. Um, and this is where I'm not entirely sure how to generate this particular use case, but this is something that my current design hat is trying to play with. I'm currently using loop as an example, and really this is movie. Because I know a lot of folks aren't big fans of loop. This is something that it's that's on my mind, but this is kind of the closest thing that I could think of. And then we could do a merge and say a acted in B. And this will then generate what we saw earlier, which is merge a person where a.name equals Keanu Reeves. Merge b.movie. Sorry, not merge. This actually is a match because we're trying to grab the nodes. Okay, where b.title equals the matrix. Merge a acted in B. And it'll do exactly what we expect it to do. So how would we go in and actually design this? This is something that I've been first trying to come up in my head as to generate this. So one thing that we would end up doing is instead of creating this here, let me go ahead and take these examples and let's create a new file and call it CYPHER.lisp. Okay. And what we'll do is we'll first create a package. Okay. Let me first comment out all this. Meta slash, sorry, meta. Wait. A second. For some reason, my comment shortcut isn't working the way I expected to. So I guess I'm going to have to do it the old-fashioned way. Okay. 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 Good. Okay. So first we'll go into packages and we're going to create a new package called CYPHER. So our CYPHER language will be in its own thing. Okay. Def package cl-neo4j CYPHER. We're going to go ahead and use Alexandria and CL mostly for its parsing utilities. We don't need actually all the stuff that's inside yes, there was a comment about my comment shortcut. Yes, it is meta semicolon, and meta semicolon for whatever reason was not working the way I expected to. I mean, I don't know why, but we'll see. See, meta semicolon is giving me a slash there to add a comment instead of commenting the current region. Anyway, what is it? So we don't, like I said, we don't need necessarily the actual things. At least I don't think we do. We don't. We may need because CL Cipher is just really a cipher parser. This is going to end up just creating cipher queries for us on the fly. And so this piece, I think at most we're going to probably want Anaphora, Alexandria, and CL. And I think the rest of it is just going to be passed into our already existing utilities. Okay. Um, and what we really want to do is export and generate um, something like Cypher query like this that would ultimately take in what we write in Cypher and spit out uh, a really nice Cypher query for us. All right. So let's go back to our design metric, and I think we're going to spend some time on different advantages and disadvantages of what I'm about to go through. Uh, let's go to. So we saw these couple of ones that we came up with. Okay, another way of kind of designing this is kind of Lisp-ish. Honestly, because you made them into S expression, but it's not completely. Another thing that we could do is go full blown um, loop. Okay, another design idea that I think there's some advantages of this, and that is if we ran Cypher query and we said create well, let's rewrite the above line 13 through 15 in this example. We would take the previous three lines, paste them, get rid of that. Then here, we really want to get rid of, sorry, B for smart parens, C, P, um, no, no, not CPSU. It's BCPWU. There we go. We want to go and unwrap these expressions. And we could run something like this, okay? This both in and of itself, let's look at these side by side to kind of see what the difference is, okay? In one case, you're looking at something that to a Lisp programmer will be like, okay, we're writing a bunch of S expressions here, all right? And what we'll do is when we read in the next X expression, we know what this first car is going to be. We know what the next set of expressions as part of the list is going to be, all right? So we can end up leveraging the read function to actually go in and take each of these expressions one at a time and allow us to actually grab the structured data here. In this case here, though, this is a single S expression as far as the reader is concerned. Okay, this is where read macros come in. This will allow you to do a character by character parsing of the actual um, expression. So within the actual macro, within the actual reader, you will end up checking to see whether you're dealing with match, um, whether you're dealing with an open paren or a closed paren, and so forth. Okay, loop is kind of designed in this guise, but I will say that you can still read. I believe you could still get this tokenized and get match a colon person where separately. But again, um, this is going to be, I'll be honest, my first foray into writing a serious macro for this generation. So we're going to be learning together on this. Um, I'm going to kind of leave some of these discussions at that and kind of just do a quick couple of basic examples for folks who haven't seen macros or have touched macros, but it's been a while. Um, Again, remember the most basic macro is probably this. Okay, so there was an example. There was a comment about Honey SQL. Um, so there was a question about Honey SQL and maybe changing closure that leverages that's written for closure. I have actually not seen this for Common Lisp. But I haven't actually played around with this either because I'm not a closure programmer. But it looks like it'll be kind of the same idea. Um, at least looking at the examples. So to show people this, um, let me show folks here. Let me share this. So the example that one of the authors is okay. Let me share my screen. So one suggestion was, let us try and leverage something like what HoneySQL does. All right, enclosure. This I'm honestly not entirely certain. Like this idea here, where you're actually generating kind of a query on the fly with this design, particularly because of two things. One, um, a Cypher query is a mixture of both, I would say, ASCII art, all right, in that you are writing in ASCII the graph relationships, the graph patterns, um, and versus in the case of SQL, you have some more of a structured level of writing projections. Um, You do have some of that when you look at match, okay? But we are writing very basic matches right now, where you are looking at the metadata within a particular node or within a particular relationship when you're writing those. But as you saw with our basic match that deals with relationships specifically, that ASCII hard stuff is still something that needs to be parsed. Now, you could argue that we could create a data structure where the edge isn't necessarily an edge that's inside of a ASCII query that we'd have to parse over. You could make a equivalent keyword or something like that to make it a little bit more structured, but I kind of think that that defeats the purpose of at least leveraging your visual representation of the patterns that you're trying to encounter. Um, there are other query languages that mimics that kind of approach. One of them is Sparkle, and I think Sparkle would lend itself to this particular design, where you're taking a data structure and you could then generate the actual query out of it. I just don't know if that would necessarily fit from folks who are used to writing their vertice edge kind of like patterns using the style that Cypher provides. Okay. Let's move on to back to our um, buffer. Um, so let's try and see if we could get at least some progress on this kind of like design here. Um, I'm gonna try and see if I could deal with the first approach here, and then maybe even try the second one at some point, just to see the differences between the different macro writing techniques, because each one of these is very different. Um, so one thing we could do is let's see, we could write a def find leader. Uh, uh, just pull this up. Hold on 1 second. I am we have a symbol macro, we have a modify macro, we have a, hold on, there is. So both of these are kind of a def macro thing generation that we could probably leverage, honestly, coming to think about it. But what you could also do is create a reader macro that puts us in a particular mode. So let's say this, not that, let's say that the brace starts a reader macro, and then in between we could also then write these three, and this would actually also generate, sorry. Let's try this again. Okay. And then this here could be written this way, and this will also generate another possibility to go and generate the same query below. So let me go ahead and move this guy around here so folks can actually see the actual generating, the actual CYPHER query that we're trying to generate. So let's just do that. So let's go ahead and see if we could write out our Lisp comprehension. Sorry, not our Lisp comprehension, our query generation. Okay. So the way we do that is we first, I'm going to first start with this one, just merely because this one seems to be probably a little easier than say writing this one, because I think, well, let's see. Let's try one of them first and then go through it. Defun CYPHER query. Actually, def macro CYPHER query is probably a better one. CYPHER query, and then what we'll do is we end up having our body being our query statements. All right. Now here, what we'd have to do is we have to first generate format nil. Okay. And what we'll do is actually probably better to do this instead of doing format nil. Let us do this instead, which is loop for statement in statements So for each statement in statement, what we'll do is we'll actually generate format nil, and we'll actually go through and generate the statement for that given uh, statement has a string. So then we'll get a collection of strings, and then what we could do is then we could concatenate them into a single query. The one thing that we need to then do is probably read each character at a time, and this will handle this particular case here. This will not handle case number 1. So I'm going to label each of these here, so we could see the differences. Case 1, case 2, and case 3. All right. So let me move this into case 1. I've got to figure that out, why that's not working. Thank you. All right. So for this one, I'm going to have to figure out how to actually read each character from the list, because now I have a list. And I have to convert that list into a car. Its car is going to be basically the name of the syntax that we're actually starting the query with, and its cdr is going to be set up to match exactly what was written by the end user. And in fact, I would make the argument that this here needs to go in here too as well. Okay. So let's go take this guy out, and this is our already generated example of writing a function using create node. And what we'll do is we'll update tx create node to actually go in and what's it? Leverage this CYPHER query API. So this guy can go away. Okay. All right. Okay, so we now have each of the individual statements. What should happen when we do this? We would have to let us see if a primitive version of this. Let's say tilde a I'm wondering if I could just simply do this, because we already have a way to go through a list. I could just use tilde a tilde and then do a semicolon. Shoot, I'm forgetting now my my syntax here. Little brain fart. Let's go back to, I think I actually did this in one of my examples. Um, to this one. Yeah, there we go. I have to do tilde caret, not that. Tilde caret. See that and do statement. And I need to quote the statement because otherwise it's not going to treat it as a list. Oh, actually, no, wait. This should actually go ahead and treat this as a list. Let's see if this works. Okay. Let's do a macro expansion of our simple query here. Okay. Can't read it unless. Okay, that's what I thought. We'd have to actually still macro expand this guy because this is being treated as a, let's see this. So the problem here is you're using stuff that common Lisp treats as symbols that mean a particular thing. So in this case, or Keanu Reeves name there, it's treating this as a package named Keanu Reeves, which obviously doesn't work uh, in in the parser because since what it's doing is it's trying to see if it needs to go in and evaluate this, tries to go look it up, and macro expansion is failing because of the fact that it's not recognizing this. These are the kinds of things that you're going to end up having to deal with debugging in the course of the next um, couple of episodes. We're going to actually have to um, we're going to encounter this and probably do some advanced macro debugging to figure out some of this stuff a little bit more. For folks who are watching this uh, on our live stream, I do understand and I do apologize. Oh, um, I do apologize. We are having some real bad technical difficulties on our YouTube live stream because it looks like it keeps on saying that the bit rate is slow. So I need to go and figure out what is going on here. So I really don't want to start digging into this particular topic for folks who are on our Jitsi meetup, just mainly because it keeps on um, spitting out the last 15 minutes. It kept on going from good to poor to good to great to poor. So I'm not entirely sure what's going on here. Um, and so I need to go and address this. Uh, but in the last 3 minutes, I'm just going to tell you what we're going to be doing next time, just because I don't want to prevent other viewers from actually seeing this and having to re-record this. Um, so next time, what we're going to do is we're going to actually expand this macro, debug this particular case, which is actually generating the basic create queries, and if anything, we'll be able to finish off the first macro that actually generates this multiple um, uh, query stuff pretty simply. The other two is going to take a little bit more time because it obviously requires us to actually write a proper parser, um, especially the reader macro one, because that's basically writing a function that reads in from a stream character by character, doing the lexical analysis, writing out what we're trying to do, and then generating the actual query itself. So we're going to actually write a real parser for this case 3. But again, I'd rather not um, leverage that when other folks are actually unable to watch this too as well. So with that, sorry for the short episode, but you know, that's what happens when your internet keeps on getting somewhat shoddy. uh, I will leave the floor to questions now for folks who are on the Jitsi channel or the stream, and guys who are actually um, able to watch the stream at a pretty decent bit rate. Um, Please let me know if you can. And apologies if it wasn't as smooth as it should have been. Um, so let me just go look quickly at the chat here. You guys using Common Lisp at your job positions? Okay, so there was a question on, am I using Common Lisp at my job positions? But never seen any, because a folk wants to use Common Lisp professionally. I personally am not using Common Lisp at my current job position. Do I would like to encounter opportunities that leverage Common Lisp? Sure, there's plenty of opportunities out there that leverage Common Lisp. And by plenty, really, I mean, it isn't that there are folks who are using, say, Clojure or what have you, that wouldn't take on a folk who is a Lisp programmer, um, or a Common Lisp programmer for that. Uh, if you want to use if you want to do Common Lisp specifically, there are companies from Grammarly out in to, I think even Google is still leveraging Common Lisp in their reservation system, to other professional what's it, some cybersecurity firms leverage it too as well for writing out uh what's it, some fuzzers and things. um Honestly, a lot of folks who tend to use Common Lisp don't heavily advertise that they're leveraging it. Um, but if you see things in the job description that say functional programming and they mention Lisp in general, unless they explicitly call out Clojure or Scheme or Racket, there's a good likelihood that they're leveraging Common Lisp or some sort of Lisp dialect along those lines, that you could then leverage the same information that you're learning from this series in those jobs. But if you're asking for specific things, I would honestly look up Common Lisp jobs in, like, say, LinkedIn and stuff, to see other opportunities that are there, because there are opportunities out there. It's just got, unfortunately, you'd have to go look at them. They're just more Python opportunities than there are other opportunities that are advertised, and those are the ones that they end up coming at. Oh yes, there's another company, Ravenpack. I forgot about them. Ravenpack actually leverages Common Lisp quite a bit too, and they have a couple of projects that they actually written in Lisp. I think they wrote the MPS. There's some sort of collector that they wrote that was also in there. Um, uh, So, question that. So I'm originally from the Midwest. So there's a question about where I'm originally from because of the use of some terms. I'm from the Midwest. Other questions? Okay. In that case, I'm going to end the stream here. I will see you guys next week on the, what's it? I think that's the second. Yeah, it's the second. I'll see you guys next week on the second. Talk to you then.